The machinist is often required to machine flat surfaces at a right angle to the cutter axis. The face milling cutter is well suited for this operation. It is held in the spindle of a milling machine on a stub arbor to machine these flat surfaces. After viewing this videotape, you should be able to write down the safety precautions that should be observed when using face milling cutters on the horizontal milling machine, identify face milling cutters, and describe the procedures for milling with a face milling cutter on the horizontal mill. To safely operate a milling machine, wear safety glasses. Keep your sleeves above the elbow. Remove watches and jewelry. Handle cutters carefully. They are sharp. Disengage the manual controls before engaging the rapid traverse. Otherwise, they will spin and could cause injury during rapid traverse. And clean away chips with a brush. A face milling cutter up to 6 inches in diameter is called a shell and mill. Cutters larger than 6 inches in diameter may have inserted teeth. These cutters come in a wide variety of diameters and widths. They may have square corners or be ground with an angle on the leading edge for longer life and better heat dissipation. These cutters are generally held in a short or stub arbor. This arbor is mounted directly into the milling machine spindle and clamped in place with a drawbar. Then the cutter is placed on the stub arbor with screws, or in the case of smaller ones, with a single bolt. When placing the cutter on the arbor, it is important that the milling machine be extremely clean. In addition, no burrs can be tolerated on the arbor or the cutter, since this will throw the cutter out of alignment and cause irregular surfaces to be machined onto the part. Face milling can be performed on a vertical milling machine with the cutter held vertically in the head, or on a horizontal milling machine with the cutter held horizontally in the spindle. Face milling is usually performed on heavier, larger vertical milling machines rather than on small, lightweight ones. For this demonstration, we will face mill a piece on the horizontal milling machine with the work held in a vise. First, align a vise on the milling machine so that the vise jaws are parallel to the cross-feed axis of the machine. Then place the workpiece in the vise. In this case, the work is low-carbon steel. We will face mill the end surface flat and machine a square on the workpiece using the edge of the face mill. Rigidity of the setup is important. The workpiece must be supported where the cutting takes place, so there should be very little overhang extended from the vise. If the work is clamped directly to the table, very little overhang should extend past the table. Select a face mill. This workpiece is less than 2.5 inches thick, so we can use a 2.5-inch diameter shell and mill. After cleaning the spindle, place the stub arbor into the spindle nose of the milling machine and clamp it with the drawbar. Make sure there are no burrs on the arbor or the cutter. Then place the shell and mill on the arbor and tighten it securely against the arbor. Once the cutter has been mounted, use the speed and feed calculator to select the speed for face milling. For face milling of soft steel, the cutting speed should be 100 to 160. Using a cutting speed of 100, calculate the RPM for running the machine. For a 2.5-inch cutter at a 100 surface foot speed, the RPM would be 150. Set the spindle RPM. Now count the teeth in the shell and mill. For face milling of soft steel, the feed rate per tooth can be 6 thousandths to 12 thousandths. We will use 6 thousandths since we want a smooth finish on one pass. Using the speed and feed calculator and setting the number of teeth under 150 RPM, we see that for 6 thousandths, the feed rate in inches per minute would be 9 inches. Note that the feed rate and spindle RPM are totally independent on the milling machine, so that both have to be calculated and set separately. With the cutter mounted, the spindle speed and feed rate set, and the work mounted in the vise, you are ready to pick up the cut and machine. Rough position the cutter with a rapid traverse. Then pick up the cut with the hand feed. Touch the cutter to the end of the work and move the work to the end away from the machine. Remember to tighten all locking levers that are not being used in the movement of the table. Also, remember to unlock and relock the levers when repositioning the table. Coolant may be used to wash the chips away and to keep the work and cutter cool and lubricated during the machining operation. A special guard is generally used to deflect the coolant back onto the table. The guard should be used in this operation, since we will be milling over the edge or very close to the edge of the table. Take a 50,000th depth of cut and clean up the end of the work by engaging the longitudinal feed and allowing the cutter to pass across the end of the workpiece. This pass gives a smooth machine finish to the work. After the end has been machined, unlock the crossfeed and move in 200 thousandths with a crossfeed handle. This will machine a shoulder on the end of the work to a depth of 200 thousandths. We also want the shoulder to be 200 thousandths from the edge of the work. Move the cutter to the top of the work and pick up a cut. Now move the work out of the way and feed up 200 thousandths with the table. Engage the longitudinal feed and proceed to cut the notch in the top of the work. When this notch has been cut, move the cutter to the side and pick up the cut. Feed in 200 thousandths with a longitudinal feed and proceed to cut the notch in the side of the work using the vertical power feed. Continue this process on the bottom side of the workpiece and the opposite side of the workpiece until you have cut a notch 200 thousandths deep and 200 thousandths in from the edge to form a square on the end of the workpiece. As you can see from this demonstration, face milling cutters can be used to cut a square notch into the side of a workpiece, since they will cut both on the face and the side of the cutter. By using the face milling cutter, we did not have to move the workpiece to perform all of these operations. This workpiece is now complete. To review, you should now be able to write down milling machine safety procedures, identify face milling cutters, and describe face milling operations on the horizontal milling machine. In the hands of an experienced operator, the face milling cutter is a useful and efficient machine tool.